Supervisors are the essential link in ensuring food safety. The supervisor's role to ensure companies' aims and objectives are achieved, to ensure the food safety policy is enforced, to develop and maintain standards and procedures, to advise management of resource requirement, to ensure standards are maintained. Supervisors' responsibilities: they must be effective communicators to staff and managers, lead by example to demonstrate commitment, instruct, train, motivate, control and monitor staff to ensure standards are achieved, to instigate the relevant corrective action. Standards are needed to ensure consistency, to provide a reference point target, to facilitate control, monitoring and auditing, may be voluntary, legal, international or in-house. High standards equals a good reputation. A food safety policy is a commitment to produce safe food. It's a commitment to ensure legal responsibilities are met. It's a commitment to provide satisfactory premises, fixtures and equipment. It outlines management, including supervisors' responsibilities. It provides a commitment to implement a food safety management system based on the HACCP principles. It's used to communicate standards, systems and operating procedures, and it's useful for training. The food safety policy should include procedures for approval and monitoring of suppliers and delivery of raw materials, for personal hygiene, screening and reporting, informing, training and supervising staff, implementing an effective training program, integrated pest management procedures, cleaning and disinfecting schedules, waste management, customer complaints, food poisoning outbreaks and hazard warnings, product recall, dealing with authorised officers such as environmental health practitioners and trading standards officers, also contractors and visitors. The HACCP system will deal with procedures related to the control of hazards, especially temperature control and preventing contamination. Quality control and quality assurance. First of all, quality control. This relies on end product testing as an indicator to consistent quality. There is significant testing to ensure safety. It's reactive. It identifies what has gone wrong but not necessarily why. It's often expensive and tests may be destructive. Quality assurance, on the other hand, is proactive, not reactive. It prevents problems before they occur. Supervisors ensure policies and procedures are effectively implemented. Action is instigated prior to the deviation occurring to avoid the need for product destruction and recall. Its effective implementation requires the specification, what is to be done, the documented instruction, how it is to be done, the recording system to confirm it has been done, the monitoring system to confirm recording and corrective actions are satisfactory. Greater confidence in the safety of foods is obtained with quality assurance, and it may assist due diligence defence. HACCP stands for Hazard Analysis Critical Control Point or Points. It's a food safety management system, or an FSMS, to secure the production and sale of safe food. It was developed in the 50s between the Pillsbury Dough Corporation, NASA, American scientists and the American military, and its main aim is to protect space travellers from the symptoms of food poisoning. You can imagine what happens to a spaceman in a sealed spacesuit if he has sickness and diarrhea. He'll literally drown in his own bodily fluids. It's a science-based documented system for identifying and assessing hazards and risks of food production and the implementation of cost-effective controls and monitoring procedures to ensure food safety. The advantages of HACCP includes its proactive, therefore its quality assurance, therefore corrective action is taken prior to problem, it reduces product loss, all staff are involved, not just quality control in the laboratory, it's cost effective because the resources are concentrated at the critical points, It may assist in a due diligence defence, and it complies with the law. It requires full commitment, multidisciplinary approach, consistent and standardised approach, detailed scientific knowledge. And here are some definitions which you'll come across when you're dealing with HACCP. First of all, control measures. These are actions to prevent or eliminate or reduce a hazard to an acceptable level. Now, for those of you who have done or been on health and safety courses, you can see that's really part of a generic risk assessment. Corrective action, actions taken when there is a loss of control at a CCP or a critical control point. Critical control point, CCP, a step where control is essential to prevent, eliminate, reduce a hazard to an acceptable level. Hazard, the potential to cause harm. Monitoring, the measurements of controls to confirm the process is under control. And verification, procedures to determine compliance with the HACCP plan. HACCP, the same as any other food safety management system, in a nutshell is preventing the contamination of food. Now, in order to prevent the contamination of food, we need to prevent the contamination by way of all the different hazards. And there are four main hazards. The first one is microbiological hazards. These are present in raw materials. Contamination could be due to pathogens. There could be multiplication of pathogens or toxin production, and the survival of pathogens, spores and toxins. Physical contamination, present in raw materials. Contamination is by way of foreign bodies. Chemical contamination, present in raw materials. Contamination can be due to excess additives or cleaning materials, etc. And allergenic hazards. This is an increasing problem. The body's immune system reacts to the allergen. Anaphylactic shock may result in death, and is present in specific types of food with varying degrees of protein, for example nuts. Before we commence on a food safety management system based on the 7 HACCP principles, we must have prerequisites in place. Now, prerequisites are requirements prior to the implementation of HACCP. They may also be considered as generic controls. And the two main prerequisites are management commitment and adequate resources. After that, we then implement prerequisite programs, and these include the use of approved and reputable suppliers, premises and equipment well designed, constructed and maintained, using a unidirectional linear product flow. You must have maintenance contract and contingency plans and segregation, suitable facilities with the use of colour coding, equipment calibration, potable water and ice supplies, good stock rotation using FIFO, first in, first out, good housekeeping, effective waste management, integrated pest management, high standards of personal hygiene, staff vigilance, effective supervision and suitable facilities, staff trained commensurate with their work activities to ensure they're competent at their job, health and exclusion policy for staff and visitors, effective plant cleaning and disinfection schedules, labelling, traceability and recall procedures, and contingency plans. Prerequisites may be essential to reduce food poisoning, but are excluded from the HACCP control chart to minimise the number of critical control points or CCPs and to avoid repetition. However, prerequisites should be considered in the verification of the total system. Under the Regulation EC number 852/2004 on the hygiene of foodstuffs, under Article 5, there is a legal requirement for HACCP, or for a food safety management system based on the 7 HACCP principles, and this became law on the 1st of January 2006. And under Article 5, it states that food business operators should put in place, implement and maintain permanent procedures based on the following HACCP principles. And those principles are as follows. First of all, identifying any hazards that must be prevented, eliminated or reduced to acceptable levels. Secondly, identifying the critical control points at the step or steps at which control is essential to prevent or eliminate a hazard or to reduce it to an acceptable level. Number 3, establishing critical limits at critical control points which separate acceptability from unacceptability for the prevention, elimination or reduction of identified hazards. Number 4, establishing and implementing effective monitoring procedures at critical control points. Number 5, establishing corrective actions when monitoring. It indicates that a critical control point is not under control. Number 6, establishing verification procedures which shall be carried out regularly to verify that the measures outlined in 1 to 5 are working effectively. And lastly, establishing documents and records commensurate with the nature and size of the food business to demonstrate the effective application of the measures outlined in A to F, or between the first and the 6 points. When any modification is made in a product, process or any step, food business operators should review the procedure and make the necessary changes to it. Under the same legislation, food business operators shall provide the competent authority with evidence of their compliance with HACCP in the manner that the competent authority requires, taking account of the nature and size of the food business. They should ensure that any documents describing the procedures developed in accordance with this article are up to date at all times. And lastly, retain any other documents and records for an appropriate period. Under the same legislation requiring HACCP, with training, food handlers must be trained commensurate with their work activities. In other words, the job that they're doing, they're qualified to do it. And persons responsible for HACCP are to receive HACCP training. Regulation EC 852/2004 requires food business operators to put into place a food safety management system based on the HACCP principles. However, the FSMS does not have to follow the traditional HACCP approach so long as the outcome is safe food. The regulation does allow flexibility. Depending on the size and type of business, this enables systems to avoid using HACCP jargon, use generic controls, use pre-validated procedures, for example by the Food Standards Agency, combine good hygiene practice and HACCP, use practical craft skills, sensory observation and supervision instead of numerical critical limits, use minimal documentation, and use exception recording, i.e. when something changes or goes wrong. Managers must have skills to maintain the FSMS proportionate to their business. Safer Food, Better Business (SFBB) takes advantages of the flexibility allowed for small businesses. SFBB is a practical food safety management system developed by the Food Standards Agency to help small catering businesses comply with the law regarding HACCP and to produce safe food. It's provided in an A4 binder divided into 2 parts. The first part provides safe methods and the second part contains monitoring records. The safe methods relate to cross-contamination, including personal hygiene, cleaning, including hand washing, chilling and cooking. In other words, the 4 C's. There is also a section on management which provides guidance on opening and closing checks, proving methods as safe, a safe method completion record, training and supervision, stock control and selecting suppliers and contractors. The second part includes a cleaning schedule, a suppliers list, staff training records and a diary to record daily events and a 4-weekly review. The safe method sheets are based on good catering practice. They identify generic hazards and critical control points and describe how to prepare safe food. Safe method sheets must be completed by each business to ensure that a pack is customized to reflect the critical control points specific to their operation. The completion of the diary and the records provide additional documentation. carrying out the self-audit, the 4 weekly review and inspections by authorised officers provide the verification of the system. The prove it part of the management section is also part of the verification principle. This could involve, for example, using a disinfected probe thermometer to confirm that a particular process achieves a safe cooking temperature, or that food can be cooled to a safe temperature in a specific time. If the food business prepares a food dish not included in a safe method in SFPB, then the owner or manager must develop their own safe method. For example, if not using pasteurised egg when making lightly cooked egg dishes or preparing a doner kebab. This will require the procedures used to be validated to prove they are safe. The manager must sign the diary every day to confirm that all safety checks were carried out and that the safe methods were followed. If something different happens or something went wrong, this should be recorded in the diary, together with the corrective action that was taken to make the food safe to eat. The pack does not require the daily use of a probe thermometer or the daily recording of, for example, a fridge or cooking temperatures. However, the correct use of a probe thermometer, for example to check deliveries and storage temperatures of the chilled food, are to confirm cooking temperatures of food and to confirm that food on display is kept below 8 degrees Celsius or above 63 degrees Celsius may enhance your control measures. Furthermore, accurately completed records should assist a due diligence defence if this is required. SFPB does suggest the use of a thermometer to validate procedures of food preparation which is not included in a safe method, for example low temperature cooking. When using probe thermometers, you must always check the warmest part of chilled food and the coolest part of food during cooking or hot holding. Thermometers must be cleaned and disinfected before probing each food and is best achieved by using hot water above 82 degrees Celsius. When you're implementing HACCP using a Codex logic sequence, there are 12 steps. The first step is to assemble and train the HACCP team if appropriate, consider knowledge required and appoint team leader, and define the terms of reference. Decide on the scope, i.e. which operation or process, which products, which steps and which hazards, which could be microbiological, physical, chemical and allergenic. Number 2. Describe the product, recipe and process. Potential hazards and risks, suitability for multiplication, processing, cooking, packaging, labelling, storage temperatures and potential customer abuse. Number 3. Identify intended use, likely customers. Could it be babies, elderly, pregnant women, ill persons or institutional feeding? Number 4. Construct process flow diagram or diagrams. Number 5. On-site confirmation of flow diagrams. Walk the talk, walk the line, to make sure the flow diagrams that you have put together are in fact what's happening in reality on the shop floor. Number 6. Identify hazards, risk, severity and control measures. And this is hazard analysis. And this is principle 1. Hazards, as already stated, may be microbiological, physical, chemical or allergenic. The examples are, for example, failure to segregate raw and high-risk food resulting in contamination, leaving high-risk foods at room temperature enabling pathogens to multiply, failure to cook to a centre temperature of 75 degrees Celsius or equivalent resulting in the survival of pathogens, sighting an electric fly killer above a food preparation surface allowing dead flies to drop into food, using harmful chemicals adjacent to open food. Control measures may be specific to a particular hazard, but in catering, genetic control measures, including prerequisite controls, are probably more common. For example, storage of all high-risk food under refrigeration at less than 5 degrees Celsius or above 63 degrees Celsius. Cooking to a centre temperature of greater than 75 degrees Celsius. Minimizing time at room temperature. Specifying size of joints, for example maximum size 2.25 kilograms. Some hazards require more than one control measure. It is often useful to avoid hazards by keeping sources of contamination out of food premises. For example, using ready prepared vegetables, using cooked chickens instead of frozen, having separate deboxing areas, specifying the type of packaging, for example no staples. There should also be a glass policy to exclude the risks from glass. Number 7, which is now principle 2 of HACCP, determine critical control points. And you may use the Codex decision tree, which we'll look at in a few minutes. A simple decision tree is preferable in catering or retailing, as the Codex decision tree, which is designed for manufacturing, is complicated and results in inconsistencies unless applied with considerable scientific knowledge. Number 8, which is principle 3 of HACCP, establish critical limits and target levels for each critical control point. Number 9, which is principle 4, establish monitoring systems for each critical control point. Number 10, which is principle 5, establish corrective actions to be taken when a CCP, critical control point, has moved out of control. Number 11, principle 6, establish verification and review procedures. And number 12, which is principle 7, establish documentation and record keeping. Here's an example of a flow diagram showing you the hazards at each stage. First of all, purchase. The hazards include the presence of contaminants, bacteria, foreign objects and chemicals. Deliveries. Hazards include presence of contaminants, multiplication of pathogens. Storage, multiplication of pathogens, contamination. Preparation, multiplication of pathogens, contamination. Cooking, survival of pathogens, multiplication of pathogens, contamination. Cooling, you've got multiplication of surviving pathogens, spore germination, contamination. And lastly, service, multiplication of pathogens and contamination. Here's an example of another flow diagram, this time for a rotisserie oven. It's much the same as the chickens that you find for sale in the large supermarkets, where they'll cook them in a rotisserie oven and serve them to you for purchase at one of the tills. First of all, you've got product supply at number 1, receipt and storage, and number 3, preparation and cooking. And at number 5, you look at the top right hand side, this is where the packaging comes into the equation. Number 5, packaging supply, receipt and storage, and that joins number 3, preparation and cooking, where the chicken is then put inside the packaging. Number 4, that's put on hot display, then served, and number 8, consumption by the customer. You need to validate or audit the process flow chart. Is it accurate for every occasion? Critical control point, CCP, what is it? Well, the definition is, it's a step in the process where control can be applied and is essential to prevent or eliminate a food safety hazard or to reduce it to an acceptable level. In other words, if you look at health and safety, it's a control measure, something which you introduce to reduce the hazard or to reduce the risk or to eliminate the hazard. Really, a critical control point is the last line of defense. After that, if a problem arises, then there could be contamination, there could be a product recall. So really it's the last line of defense. The determination of the critical control points is fundamental to an effective HACCP system. So we use the critical control point decision tree. This is an example of the simplified decision tree, and it's probably the best one that you can use. So the question is asked, if I lose control, is it likely that food poisoning, injury or harm will result? This includes dangerous foreign objects, burning, chemical poisoning or the presence of allergens. If the answer is no, then it's a control point, or a CP, or good hygiene practices, for example GHP. If the answer is yes, then you ask a second question. Will a subsequent step eliminate or reduce the hazard to a safe level? If the answer is yes, then it's a control point. If the answer is no, then it's a critical control point. And this is the Codex CCP decision tree, and you can see straight away it does look a very complicated structure, and it is complicated. There are too many questions asked, there are too many steps in the equation. So I would advise you use a simplified decision tree. For example, I can go through this. Question 1, are control measures being used to prevent the hazard? If the answer is yes. Question 2, does the step eliminate or reduce the hazard to an acceptable level? If the answer is yes, it's a critical control point. If it's no, first of all, is a control step required for safety? If the answer is yes, go back up, modify step, process a product, and ask question 1 again. If the answer is no, then it's not a critical control point. Proceed to the next step in the process. After question 2, if the answer is no, you go on to question 3. Does contamination occur at unacceptable levels, or could it increase to unacceptable levels? If the answer is yes, we go to question 4. Will a subsequent step eliminate or reduce the hazard to an acceptable level? If the answer is no, it's a critical control point. If the answer is yes, it's not a critical control point. Proceed to the next step in the process. And if we go back then to question 3, does contamination occur at unacceptable levels, or could it increase to unacceptable levels? And if the answer is no, then if you move to the right hand side, not a critical control point, etc, etc. So you can see that is quite a complicated method. So I would advise, if you are engaged in HACCP, to use a simplified decision tree. And the simplified decision tree, as we've already gone through, is a way of determining if a point in the process is a critical control point. And the recommendations from various experts, food experts, etc., say that you should have as few critical control points as possible. Don't try to put critical control points at every step in the process, because you will find then you'll be not concentrating your resources, your monitoring, at the critical control points. You'll be monitoring at ordinary control points. So there could be the possibility of more expense, for example. Supplier monitoring. The amount of supplier monitoring carried out by companies is dependent on the size and turnover of the business. Small companies may have to rely on the reputation of their suppliers. All companies should ask for copies of their suppliers' food safety policy, HACCP documentation, and monitoring records. Specifications should be set and deliveries checked for compliance, with some sampling results. References from other companies should also be sought. Past records used if they are an existing supplier. Comparison of actual standards with those outlined in the company's food safety policy is essential. Staff competency is an indication of standards. Wherever possible, audits or inspections of suppliers should be carried out, either by the company's own hygiene officers or by external consultants. All official certificates should be in order. Remember, a due diligence defence can only be relied on if reasonable care has been taken to ensure the safety of incoming goods. Monitoring is required to ensure that control measures remain in place and are effective. In other words, that the CCP critical control point is under control. It identifies deviations, i.e. moving out of control, and it triggers corrective actions. Monitoring systems provide records for verification, identifying reasons for complaints, and assisting with due diligence. Monitoring must permit rapid detection and correction. It may be manual, automatic, continuous, or at set frequencies. Monitoring systems should state the following. What are the critical limits? For example, 8 degrees Celsius for 4 hours. What are the temperature requirements? What time at that temperature? What are the target levels? For example, 5 degrees Celsius. What are the tolerances? For example, 3 degrees Celsius. How? Given detailed methodology, for example, automatic timing. The equipment to be used, for example, temperature probes. Calibration requirements, which are often forgotten. The next one is where? At the control point or critical control point, or as close as possible to the control point or critical control point. Whom is responsible for monitoring? Training requirements of personnel. Ensures monitoring is undertaken correctly by auditing. When? What's the timing of the monitoring? What are the frequencies of monitoring? And lastly, records. Accurate records must be maintained. They must be kept up to date, signed and dated, and filed. Poor records will damage a due diligence defence. When you're using probe thermometers, you should not use a bimetallic stem thermometer like the one shown in the slide. Bimetallic stem thermometers are not tip sensitive and they cannot be calibrated. A digital electronic probe thermometer should be used to measure storage and cooking temperatures. And as already mentioned, you should not use a bimetallic coil thermometer, you should use a thermocouple probe thermometer, much like the one shown in the slide. That probe thermometer you can calibrate and it is tip sensitive. Probe thermometers should be calibrated monthly in ice and boiling water. The temperature should read 0 degrees Celsius plus or minus 1 degree Celsius when the probe is inserted into melting ice. That's the diagram in the first part of the slide. The temperature should read 100 degrees Celsius plus or minus 1 degree Celsius when the probe is inserted into boiling water. Probes which are more than 1 degree Celsius adrift should be replaced. External calibration is recommended annually, and this is usually undertaken by the manufacturer of the probes themselves. When they are calibrated, the manufacturer will supply a certificate to guarantee that it has been calibrated. Cross-contamination. Probes should be cleaned and disinfected between each use. Never probe raw food and then ready-to-eat food without disinfecting in between. Always make sure the probe is then thoroughly cleaned before storing in disinfectant solution. Water above 82 degrees Celsius can be used to disinfect probes. In fact, it's a preferred method rather than use chemicals. Several different methods of monitoring are employed to ensure control measures are effective. For example, bacteriological testing. This is only used if the test results are rapid, not traditional, because that can take a long time. Organoleptic assessment of food using your senses, such as smell. Good food should smell fresh, pleasant and natural. Unusual stale, musty or rancid smells should invite suspicion. Chemical smells normally indicate chemical contamination. Fatty foods can pick up taints from other foods. Taste, another organoleptic sense. Unusual bitterness, sweetness, a soapy taste or any untypical flavour may indicate unfitness. Appearance. Food should be visibly free from signs of spoilage, fungal growth, slime, darkening, or other change in colour, untypical wetness or mechanical damage. Absence of foreign objects, dirt, etc. is also essential. Meat and vegetables should be free from evidence of disease. Excessive ice crystals may indicate mishandling in frozen foods. Sound. Many packed foods, especially canned goods, emit a characteristic sound on being tapped or shaken. And texture. Unusual softness, hardness, brittleness, or change in texture may indicate unfitness. Meat, fish, etc. should display a springy texture. Pitting on pressure can be a bad sign. Other methods of monitoring include checking controls and records, audits, visual inspections of premises, vehicles or practices, competencies testing of staff and supervisors, and food complaints, the type, number and trends. Bacteriological monitoring may be used to assist HACCP verification, assist hazard analysis, build up a profile of product quality, indicate trends in product quality, ascertain whether handling techniques are satisfactory, indicate safety and the absence or levels of specific organisms, determine the effectiveness of cleaning and disinfection, determine the effectiveness of product processing, confirm that legal standards are being met, confirm that customer standards are being met. The number of bacteria depends on the raw material, hygiene standards. Fucking hell. Food process, packaging, temperature, etc. Interpretation of results. Now you'll probably see a phrase called TVC, a total viable count. This is an indication of the numbers of organisms present, but it's only effective as indicating trends if the details are the same. For example, area, incubation time, media used, incubation temperature, etc. If, for example, Staphylococcus aureus is present, this usually indicates bad personal hygiene. If Escherichia coli is present, usually indicates fecal contamination in one form or another. Salmonella usually indicates fecal contamination, possibly via poultry, or insufficient cooking or cross-contamination. And if there's any Clostridium perfringens present, this usually indicates fecal or soil contamination and or slow cooking. Interpretation of results. Guidelines for the microbiological quality of ready-to-eat foods, as published in September 2000 by the Public Health Laboratory Service, is as follows. Aerobic colony count, where the colonies are held at 30 degrees Celsius for 48 hours, and it shows the total number of colonies or organisms present. If comparing trends, incubation time and temperature and media must be constant. Indicator organisms used, Enterobacteriaceae, which are more accurate than coliforms. However, fresh fruit, vegetables and salad vegetables have high levels in their normal flora, therefore may not indicate a problem. Escherichia coli total usually indicates fecal contamination and major risk of pathogens. Listeria species in total indicates potential for the presence of Listeria monocytogenes. Pathogens: Salmonella, Campylobacter and E. coli 0157 and Vibrio cholerae should not be isolated even in small numbers. Their presence indicates fecal or cross-contamination or inadequate cooking. Vibrio cholerae has been isolated in fish products, fruits and vegetables imported into Europe. Listeria monocytogenes counts of 10 to the power 2 CFU may indicate poor hygiene standards or storage conditions. Foods with this level are potentially hazardous. Management audits. Supervisors must use daily checks to ensure that premises and equipment are clean and in good repair, that food is in good condition and within shelf life, that no hazards are evident, including signs of pests, that food equipment temperatures are satisfactory, controls are in place, that all records are completely satisfactory, records are not fudged, all hygiene practices are satisfactory, no evidence of shortcuts, no cross-contamination potential, staff are competent and following hygiene rules, and signage is satisfactory. If management cares, so will staff. At the start of the day, premises, equipment and services should be cleaned and disinfected. Adequate supplies of soap, drying facilities and cloths should be at hand. All food handlers should be fit and clean, including protective clothing. Fridge and freezer temperatures should be satisfactory. At the end of the day, all waste and rubbish should be removed. Premises and equipment cleaned. Date codes of food checked and discard out of date foods. Fridges, freezers, the temperatures should be satisfactory and correct loading. Management audits then demonstrate commitment to food safety. Corrective action is the action taken when a control point moves out of control or is starting to move out of control. It is essential that suitable corrective action is instigated without delay. This should be as simple as possible. Procedures for corrective action should specify the following. The action to be taken when the target level has been breached. The corrective action should be taken when a critical level is breached. The person responsible for the corrective action. Who should be notified when corrective action has been necessary. Whether production and sales should be stopped. The treatment of the affected product. At what stage should recall be necessary. and who can authorise production or sales to restart. And with traceability, it's essential that the source of every ingredient of a particular product can be traced back to its supplier. If a problem occurs, the supplying company can be informed, or in the case of a serious or recurring complaint, a new supplier can be sought. Verification is the application of methods, procedures and tests and other evaluations in addition to monitoring to determine compliance with the HACCP plan, and it includes prerequisite programs. Validation, this is where elements of the HACCP plan are effective. HACCP audits, random sampling, testing of product such as microbiological, chemical and visual. Re-examine all data of any changes in ingredients, preservatives, etc. occurred. Examine documentation, monitoring records and skills of monitors. Confirm CCPs are under control. Observe staff and operations. Review of deviations and customer complaints. Are there any serious complaints? Are there any recurring complaints? Do the complaints indicate lack of control? Validation is the obtaining of evidence that the elements of the HACCP plan are effective, i.e. checking that hazards will be controlled. Now the difference between verification and validation you employ before you start the HACCP plan, the Food Safety Management Procedure, and that's only done at once. Verification is ongoing as HACCP continues. When do we review the HACCP plan? Certainly at regular intervals, a minimum of annually, if new scientific data emerges, when a justified complaint occurs, if an associated illness occurs, when raw material or suppliers change, when there's a recipe change, when there's a major change of equipment, when there's a change in the process, if storage conditions change, if product use changes, if packaging or distribution is changed, if cleaning procedures are changed. Also, review documentation must be dated and recorded. So what documentation should be retained? First of all, the HACCP plan and details of how it was developed, prerequisite programs, a floor plan, the approved supplier list, and monitoring records, which should be signed and dated. Other records include CCP monitoring activities, temperature, date, time, weight, foreign bodies, including corrective actions and recalls, modifications to the HACCP system, inspection and audit reports, staff records, training and exclusion, customer complaints, results of tests and samples, prerequisite program monitoring activities, calibration of instruments, cleaning schedules, equipment maintenance and servicing, and pest control book. Let's have a look at a generic flow diagram for catering. First of all, the key, CCP stands for critical control point, C, contamination, M, multiplication, and S, survival. Note well, environmental and cross-contamination, pest control, cleaning and disinfection, personal hygiene and waste management are all prerequisite programs. This is the generic flow diagram for catering then. If you are involved in HACCP, then it might be worth writing down some details or some précis points for the next two slides. First of all, purchase of food. Here the hazard could be contamination, which is C. We should be using approved suppliers, so again that is a prerequisite program. Delivery, problem there could be multiplication, and if you look just to the right of that, delivery should be less than 5 degrees Celsius for chilled products or less than minus 18 degrees Celsius for frozen products. Then just under delivery, where it shows the arrow, make sure there's a minimum time to unload, between 15 and 30 minutes. Then you've got storage, again possibility of multiplication, and we can store in one of three places, either in the dry goods storage area, in chilled areas where the temperature must be less than 5, or in frozen areas where it must be less than minus 18. From frozen, that needs to be thawed with the possibility of multiplication could take place. Thawing should take place at less than 10 degrees Celsius. Thawing then moves on to preparation, where there's the possibility there of multiplication. So ensure that the food that's been prepared is out for less than 1 hour in ambient temperature. From preparation, that could be going straight then to serving cold, and there's the possibility or the potential then of contamination and multiplication. And to continue with the second part of the generic flow diagram for catering, now we could be, after we prepare the product, if we're not serving it cold, and if it's a raw product for example, then we need to cook it. So then we go on to cooking to greater than 75 degrees Celsius. There's a potential there of 3 hazards: CMS, contamination, multiplication and survival. Now we could be serving hot, and if we are serving it, we need to serve it in the quickest time as possible, in less than 15 minutes. And there the potential for 2 hazards are contamination and multiplication. From cooking, that could move on to preparation. If you need to prepare food after cooking, slicing, jointing poultry, etc. There the potential is for contamination and multiplication. Then preparation is in as little time as possible, and it shows there just under preparation less than 30 minutes at ambient. So preparing small amounts and preparing them in less than 30 minutes. Now from preparation, that could go to hot, hold and serve. So the product needs to be kept above 63 degrees Celsius, which is out of the temperature danger zone. Again, with hot, hold and serve, you get the potential of C&M, contamination and multiplication. From preparation, we could move down to cooling. Plus we've cooked the food, it's going to be served cold, so we need to cool it as quickly as possible. During that cooling process, there's the potential for C&M, contamination and multiplication. The ideal scenario would be to cool the product down to less than 5 degrees Celsius within 90 minutes using a blast chiller. Or you could use other systems, for example bring it down to less than 10 degrees Celsius within 4 hours. So once it's cooled, it goes into chilled storage, where it must be held at less than 5 degrees Celsius, and there's a potential there for C&M, contamination and multiplication. From there we could serve cold, again potential for contamination and multiplication. From chilled storage, we could then go to the last section, which is the use of leftovers, again a potential for contamination and multiplication. Or from chilled storage we could go to reheat and serve, where we've got CM&S, contamination, multiplication and survival. Now if you have a look at that flow diagram, there are 8 critical control points, which in any flow diagram are far too many. You should be aiming between 4 and 6 maximum in any catering operation. It's very unlikely that you would have all the processes or steps that are showing in this flow diagram, but it's there as an example that obviously you can pick and choose between whichever systems and processes that you have in your own operation. The more critical control points you've got, the more expensive it's going to be to monitor. That's the end of lecture 12. So here are the key points. Managers and indeed supervisors have a key role in food safety. Standards ensure consistency and customer satisfaction. Food safety policies should demonstrate the company's commitment to operate high standards and produce safe food. QC is reactive and QA is proactive. HACCP systems identify hazards, the implementation of controls and monitoring and corrective action, and provides documentation, verification and review to ensure safe food production. Bacteriological monitoring and sampling assists in the provision of food safety.